Section 4, we're going to talk about multiplying and dividing both fractions and mixed numbers. We're going to first just focus on multiplying fractions and mixed numbers first. If you have just two fractions, so no mixed numbers, the steps to do are to set them up like side by side, and you multiply the numbers in the numerators, which would be the numbers on top, and then you multiply the numbers in the denominator, so those would be the numbers on the bottom. Then when you get your final answer, make sure that you reduce. Now you can also reduce before you multiply. So if you want to do that first, you can. That way you're not having to reduce at the end. It also helps so that you don't have to deal with really big numbers if you have a lot of fractions that you're trying to multiply with. If they say something like, find a half of a fourth, that's just a multiplication problem where you're going to end up taking 1/2 times 1/4. So like that. So we're just setting it up. Now we multiply, like I said, across the top, so you're going to take 1 times 1, and then on the bottom 2 times 4. So 1 times 1 would be 1, 2 times 4 is going to be 8. So final answer would be 1/8. Okay, so why don't you guys try number 2. Find 1/3 of 3/5. So what did you guys get for a final answer? 1/5? Anyone else get 1/5 out there? Good. So when you start, you're taking 1/3 times 3/5. You could do what I did. You could take 1 times 3 and 3 times 5. You can also, because you have a 3 in the numerator and a 3 in the denominator, and they're across from each other like that, you can cancel them out. You can reduce them. So these would both reduce to a 1. So then if you did the math, it'd be 1 times 1 and 1 times 5. And that's just by reducing beforehand. So we get 1/5. If you didn't reduce, you would get 3/15. Then you would have to take a 3 out of both. So you would still have to reduce it. You would still get down to your 1/5. So it shouldn't matter which you decide to do. It's just, like I said, sometimes it's nice to simplify first, because then you're dealing with smaller numbers and your answer is already going to be reduced at the end. Now if they start throwing in extra fractions like this next one, we have 3 fractions that we're trying to multiply here. 2/3, 5/9, and then 1/6. So I'm going to start by just writing them out side by side. And I would look and see, are there any numbers that I could possibly reduce here? The 2 and 6? So 2 can go into both 2 and 6. So this 2 becomes a 1. This 6 becomes a 3. So now when you multiply, just because we've added extra numbers doesn't change the rules. We're still going to take 1 times 5 times 1 on the top, 3 times 9 times 3 on the bottom. So we get 5 over, anyone know what the bottom would be? Good, 81. And that should already be reduced because we did our reducing before we even multiplied. So we shouldn't have to do any simplifying there. So I want you guys to try this next one. Reduce first if you can, and then multiply. So what do you guys see that we could simplify first before we even try to multiply? 5 and 10? So you made 5 become a 1, 10 became a 2. Okay, what else could we do? 2 and 12? Which 2? The original one or the new one? It really shouldn't matter. So if you wanted to, you could just get rid of this 2 altogether and make it a 1. And this would then become a 6. What else could we get rid of? Could I just get rid of the 6's? If I can cancel these out, it's easiest if we have 1s, because 1s don't really affect a problem when you're multiplying. Alright, so on top now, what I've got left is 2, and then I change the other 2 fractions to 1s. On the bottom, I have 1 times 21 times 1. So final answer should have been 2 over 21. All right, now let's get into how to multiply if we have a mixed number. If you have mixed numbers and you're trying to multiply them to either a regular fraction or another mixed number, you want to try to make those first become improper fractions. So we talked about that last section of changing fractions to improper. You take the whole number times the number in the denominator, add the number in the numerator, and that becomes the new top, and then you put that all over that original denominator. So I would change them first, then see if there's anything you can reduce, and then multiply like we've been doing. So this first one I have 2.5 times 5 1/3. So 2.5, if we change that to an improper, 2 times 2 plus 1 would be 5, so that becomes 5 over 2. What would the second fraction be if I wrote it as an improper? Good, 16 over 3. Is there anything that we could reduce before we multiply? So 2 becomes a 1, 16 becomes an 8. So 5 times 8, and then 1 times 3. What would be 5 times 8? So we have 40 over 3. Now, I don't care if you leave it improper here. If the book tells you, or if the problem tells you to change it to a mixed number, then change it. But I'm okay if you guys leave your answer here. Improper fractions don't bother me. But if you wanted to change it, it would be 13 1/3 would be the mixed number. I'll take either answer there. All right, let's take a look at a story problem. So bedding plants are to be planted 3 5/8 inches apart and 3 5/8 inch from the end of the planter. What length of planter is going to be needed for 9 plants? So if we think about this situation like being set up, you've got 9 plants. They each need to have 3 5/8 apart from each other. But then we also need there to be 3 5/8 inch from the end of the planter. So we have actually 10 spaces that need that 3 5/8. So what I'm going to do is take 3 5/8 and I'm going to multiply that by 10. That takes care of the 9 planters and it takes care of the space from the edge. Let's take 3 5/8 and let's make that improper. So what would be 3 times 8? Plus 5. So we have 29 over 8 times 10. Now, how could we write 10 as a fraction? Good, put it over 1. Can we reduce anything? How would they reduce? What are you taking out of both of those numbers? So it becomes 4 and 5 if you take a 2 out. All right, so then we have 29 times 5 on top, 4 times 1 on the bottom. And so we would end up with 145 over 4. Which would be the same thing as 36 1/4. And our label here would be inches. So we need it to be 36 1/4 inches long in order for this all to work out spatially. Okay, we've got another one here. It says bricks that are 2 1/4 inches thick form a brick wall, and they have 3/8 inches mortar joints. What is the height of the wall above the foundation after 9 courses? So the bricks are all 2 1/4, and then each joint is 3/8, and we're doing this 9 courses would be like 9 times. So we have to take 9 times both of those two numbers, 9 times the 2 1/4, and then 9 times the 3/8. What do you think we're going to do with those two numbers, though, to find like the total? Add them. Good. So you're going to put a plus sign in the middle. So what would be 2 1/4 as an improper fraction? Okay, so my first problem is going to say 9/1 times 9/4 plus, we've got 9/1 times 3/8. So what's going to be 9/1 times 9/4? Good, so 81/4 plus, what's the second one going to say? So now we're back to adding fractions. That's what we did last section. What can I do to this first fraction to get it to be a like fraction with this one? How do I get the bottom to match? Good, times by 2. So we only have to do that to this first fraction. Take the top times 2 and the bottom times 2. So I'm going to get 162/8. I'm going to add that to 27/8. Okay. At this point, with some of this too, grab a calculator and do some of these additions for you. You don't have to do all this in your head. Then you're going to get 189/8 when you add those, which would be the same thing if we divide and we try to change this to a mixed number. 8 can go into 189 23 times. And then it has a remainder of 5. And then over 8 inches. So that's the height of the wall above the foundation after they've done this 9 times, 9 courses. So the last thing I want to show you guys when it comes to multiplying fractions is if we have a fraction raised to a power. So remember, powers would be exponents. So if you have an entire fraction that's raised to the second power, to the third power, to the fourth power, they want you to take that exponent and apply it to both numbers, one like in the numerator and in the denominator. So if you're squaring something, you have to square the top number and square the bottom number. So when I have 2/3 squared, I need to take 2 squared and 3 squared. So what would be 2 squared? 4. How about 3 squared? So answer would be 4/9. So you guys do the second one there. Take 1/2 to the third power. So you're going to do 1 to the third, 2 to the third. What'd you guys get? Good. 1/8. All right, let's get a little bit into dividing fractions. When we divide fractions, we actually end up making the problem become a multiplication problem. Because dividing fractions can be kind of messy. If you take a fraction divided by a fraction, it's actually known as a complex fraction because you've got a lot of fraction parts in there. So what we can actually do is use something called the reciprocal. And you guys probably talked about the reciprocal couple years ago, like maybe back in Algebra 1. It's when you take a number and you flip it upside down. So it's a number as a fraction and you flip that whole thing upside down. So it's like it switches places. Now if you have a whole number and there is no fraction part, you just write it as a fraction by putting it over 1. The idea when we're working with reciprocals is if I multiply a number times its reciprocal, I get 1. Because the cross product should be the same. Like there should be the numbers that are the same across each other, so they reduce and you get a big 1. Another word that has maybe been used for reciprocals is called the multiplicative inverse. So multiplicative inverse, probably when you guys were in Algebra 1, you learned about properties of numbers, and we talked about the multiplicative inverse, and that actually went in and said it's when you find the reciprocal, and when you multiply them, you get 1. And when that happens, so a number times its reciprocal or times its multiplicative inverse, when we get 1, that's known as the multiplicative identity. So in order to find the reciprocal, like I said, you have to have your number in fraction form. So that means if it's a whole number, you put it over 1. If it's a mixed number, change it to an improper fraction first, and then flip your fraction upside down. So we're going to work on finding some reciprocals here. I'm going to give you guys a little bit of time. I want you to go through, there's 1, and then there's 7 on the next page. I want you to try to just find the reciprocals of those numbers as you can. If there's ones that you don't know how to do, skip over it and we'll end up coming together and talking about them. But I want you guys to try to find the reciprocals. Take those fractions and flip them upside down. All right, so if you flip the first one upside down, what did you get? Good, 7 over 4. How about number 2? 5. Some of you might have written 5 over 1. You don't have to keep it over 1. You can just leave it as the 5. How about number 3? Good, 1/3. Okay, number 4? 2 over 5. Because first, if you change this to a improper fraction, it's 5 over 2. So then the reciprocal would be 2 over 5. Did anyone do number 5? 10 over 8. 5 over 4. So 0.8 would be what as a fraction? 8 over 10. So they wanted you to write it as a fraction first, even though they're giving you a decimal. Then if you flip this, it becomes 10 over 8, but that can get reduced because we can take a 2 out of both. And so we get 5 over 4, and I'm okay if you guys leave it there. What would be the reciprocal of 1? 1. How about 0? 0 actually doesn't have a reciprocal, technically. So we would say no reciprocal for this one. Because you can't write 0 as a fraction, because 0 over 1 would just still be 0. So it doesn't matter how many times you try to do that, it's just not going to work for us.